In this video, we'll look at the angle-angle similarity postulate between triangles. We'll start with the triangle sum theorem, that the sum of the three angles of any triangle is 180 degrees. So if I wanted to find the measure of angle B there, I would observe that the measure of angles A and C are already given. When I add those together, I get 100. So the measure of angle B is 180 minus 100 degrees, or 80 degrees. So here's another triangle. If I wanted the measure of angle E, it would also be 80 degrees. The angle-angle similarity postulate states if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So let's look at the two triangles from the previous slide. We can now write a similarity statement that these two triangles are similar because of the fact that two angles of one is given as congruent to two angles of the other. So the order of the letters will matter when we're writing our similarity statement. We're going to say that triangle ABC is similar to triangle DEF. Determine whether the triangles are similar. If they are similar, write a similarity statement. So we have two right angles. So we know that angle G is congruent to angle L because right angles are always congruent. We have that we can determine the measure of angle F is 29 degrees by the triangle sum theorem. So we know now that angle F is congruent to angle J by the definition of congruence. If two angles of the same measure, they're congruent. And now I can state that the two triangles are similar. I can say that triangle GFH is similar to triangle LJK by the angle-angle similarity postulate. There's other ways I could write that similarity statement. I didn't have to start with the letters GFH in that order. I could have started with triangle HGF, and then I would have said is similar to triangle KLJ. In this diagram, it looks like one triangle is almost fitting inside another like a puzzle piece. Let's pull these triangles apart. Let's notice that angle R is congruent to itself by the reflexive property of congruence. Let's note that angle S and U are also given as equal in measure, therefore they're congruent. I have now enough information to write my similarity statement. Let's write triangle RST is similar to triangle RUV by the angle-angle similarity postulate. Here we have two triangles. They look similar, but to prove that they're similar, I must show that two angles of one triangle are congruent to two angles of another triangle. I can tell in triangle RST that the measure of angle S is going to be 35 degrees by the triangle sum theorem. I can now apply the angle-angle similarity postulate. So let's kind of write this stuff out formally. We know that angle R and angle M are given as equal in measure, therefore they're congruent. The measure of angle S is 35 degrees by the triangle sum theorem. Angle S then is congruent to angle N, just by the definition of congruence. So triangle RST is similar to triangle MNL. We looked at an example similar to this in a previous slide. We can tell that there are two triangles, it's just one is fitting inside the other. We can write these separately. We now can see that angle G is going to be congruent to itself. Angle H and J are given as congruent. So triangle GHL is similar to triangle GJK. This example is a little bit different because not only are we looking at angle measures, but we also have side lengths, one of which is an unknown. So we're supposed to find the value of that variable. First thing we want to notice is two angles of triangle ABC are given as congruent to two angles of triangle DEF. So we can write a similarity statement. Triangle ABC is similar to triangle DEF. Now we can write a ratio of corresponding side lengths in each triangle, because if they're similar, their ratio of side lengths will be equal. So I can say that that left side, 5, is to the base 15, as 3 is to y. And now to solve this proportion for y, there's a bunch of ways I could solve that. I like to look for relationships in the numbers. I can see that in the first fraction, the numerator times 3 equals the denominator, right? 5 times 3 equals 15. So in the second fraction, 3 times 3 equals y, so y equals 9. One last example, we have two triangles. We want to write a similarity statement and then find the value of the variable z. First thing we want to notice is we have what we call vertical angles. Vertical angles are congruent. And now I have two angles of one triangle congruent to two angles of another triangle. My similarity statement then is going to be triangle ADB is similar to triangle ECB. And when I write my proportion, this time let's just use the order of the letters in the similarity statement itself. I'll show you what I mean. Let's do AD is to AB as EC is to EB. Now that I've noticed that, I can write down the measures right from the diagram. 6 is to 12 as some number z is to 6. And my relationship that I'm noticing in these fractions is that 6/12 is the same thing as a half. So z would have to be 3.